Imagine taking the dirt and dust you just kind of swept off your kitchen floor, throwing it into a box, and, pouring out premium liquid fuel for your car.
Right. I mean, it sounds like complete magic.
Yeah, exactly. But, well, today's deep dive is about doing exactly that, just on the scale of an entire forest. So welcome in.
Thanks. Yeah, we're looking at this really strategic proposal from New Zealand's Parengarenga Incorporation, or PINC.
Right, and our mission for you today is to explore their waste-to-wealth circular economy model.
Which is aiming to turn forestry debris into actual regional energy sovereignty, which is huge.
Okay, let's unpack this. Why energy sovereignty specifically?
Well, the stakes are incredibly high. New Zealand is sort of at this vulnerable end of the line for global supply chains.
Right, like with oil prices constantly shifting around due to overseas instability.
Exactly. So this project is strictly domestic. For PNC, it's really about Tino Rangatiratanga, which means true sovereignty.
So they're insulating the Northland region from those global fuel shocks.
Yeah, literally fueling their own survival using the land they already manage.
But to get that kind of independence, you obviously need fuel. So PNC looked at what they had an absolute abundance of.
Right, which is 11,000 hectares of forestry, and specifically the massive amount of waste that it leaves behind.
Like the slash.
Yeah, exactly. So currently, about 10% of their harvested biomass, the slash, is just left sitting on the forest floor.
Which is a major problem during extreme weather, right?
Well, a massive problem. That debris just washes away, and it causes this devastating siltation in the local harbor.
Okay, wait, hold on a second. If the solution is just gathering up all this scrap wood and destroying it, how is this not just some glorified, environmentally disastrous bonfire?
Well, what's fascinating here is that it is absolutely not a bonfire. They aren't just burning the wood for heat.
Oh, okay. What are they doing there?
They're chemically deconstructing it. It's this advanced thermocatalytic cracking designed to capture 2.46 petajoules of annual energy.
Thermocatalytic cracking.
Right.
How do you destroy wood without actually burning it?
By using extreme heat in a totally oxygen-deprived environment. So instead of combusting, the intense heat forces the actual molecules of the wood to just snap apart into raw gas.
Wow. And they use a specific machine for that, right?
Yeah, it's a proprietary linear gasifier. It has a specialized hearth made of a nickel-chromium alloy, and it runs at like 800 to 1,000 degrees Celsius.
That is insanely hot.
It really is. And the nickel actually acts as a catalyst, aggressively breaking down those stubborn, long-chain wood tars into clean carbon monoxide and hydrogen gas.
Okay, so step one, break the solid wood down into raw gas. But then they have to wash it.
Right. As the scorching hot gas exits, it's forced through what they call a water marble scrubber.
Which is literally water and glass marbles.
Basically, yeah. Imagine a curtain of water falling over a bed of glass marbles. It rapidly quenches the gas and physically traps heavy metals.
So the metals get pulled safely into the water stream. But here's where it gets really interesting, because we still have a problem.
Right, the nitrogen.
Exactly. The gas is mixed with a bunch of useless nitrogen from ambient air, and you can't run a logging truck on dead air.
No, you really cannot. That nitrogen is complete dead weight. So to fix that, they pass the mixture through a Sabatier reactor.
Which injects it over nickel pellets, right?
Yes, which triggers a reaction merging the carbon monoxide and hydrogen into a single high-energy molecule, which is methane.
Okay, but now we just have methane gas mixed with nitrogen gas. How do they actually separate those two?
So they run it through a cold box. It's essentially a cryogenic freezer.
And that drops the temperature down to like minus 162 degrees Celsius, right?
Exactly. It drops it so drastically that the methane actually turns into a liquefied natural gas, or LNG.
It's almost like a distillery running in reverse.
Yeah.
Instead of boiling things to separate them by how fast they become gas, they freeze them.
Yeah, to separate them by how fast they drop out as a liquid, that is the perfect way to look at it.
But what happens to the nitrogen?
Well, useless nitrogen requires much colder temperatures to liquefy, like minus 196 degrees. So it stays a gas, and they just vent it away.
Leaving you with pure liquid methane. And it's so dense, it gives their local logging trucks the exact same range as diesel.
Right, which is incredible. But, the craziest part of this waste-to-wealth setup is it doesn't even stop at the liquid fuel.
Oh, yeah, the literal waste left over from the gasifier is actually another high-value asset.
Yes, the ash. Because of that intense chemical process, the ash is packed with calcium and magnesium.
So it acts as a fast-acting lime fertilizer for local farms.
Exactly, and it saves them over $330,000 annually at scale.
Wow. Plus, they're actively integrating industrial hemp into the forest estate, right?
Yeah, to really speed up the whole cycle. Hemp grows incredibly fast.
We're talking rapid biomass in just 90 to 120 days.
Right. And it sequesters 15 tons of CO2 per hectare while it grows.
It just creates this beautiful biocircular synergy.
It really does. You have the mineral ash feeding the soil, that soil grows the hemp, and then the hemp feeds right back into the gasifier.
To make more fuel and electricity for their microgrid. So what does this all mean for you?
Well, it means true resilience requires looking at your local nuisance waste as your greatest potential asset.
Think back to those floor sweepings we talked about at the very start.
Exactly. I mean, if a single regional incorporation can use these modular chemical skids to transform storm risk, wood debris, and hemp into a completely independent multi-million-dollar fuel and microgrid network.
Wait, sorry, it just changes the way you look at industrial byproducts entirely.
Oh, absolutely.
Which leaves you with this to mull over. If they can do all that, what waste in your own local industries is secretly a massive untapped energy reservoir just waiting for the right catalyst.
Engaged.
We are analyzing a single source on New Zealand's Northland Manuka honey production.
Confirmed.
And our mission here is to uncover how they combine this sort of ancient rhythm of beekeeping with heavy-duty industrial engineering to create this really potent, sustainable superfood for you.
The core idea is that healing the people and healing the land are treated as like the exact same profit and loss statement.
Okay, so let's start with the people then. The plan centers on something they call, which is that residential facility. But the documents make it really clear this isn't some standard rehab facility.
No, it's much more active. They use a model called the Putama, which is, it's like a stairway to knowledge. It basically treats recovery as a workforce development pipeline.
The pipeline. Yep.